Now, observe that remark. Suppose we have to find limit x tends to 0 sin x upon 6x square, sin x upon 6x square. So here in this case we does not substitute x equal to 0 directly in the denominator, because when we substitute x equal to 0, denominators becomes 0, and again the numerator is also having a 0 value, because here suppose we directly substitute x equal to 0 at x equal to 0 at x equal to 0, the numerator and denominator, n means numerator, d means denominator. Here sin 0, so that answer is 0, and denominator 6x square, 0 square 0 into 6 becomes 0. So numerator is 0 and denominator is also 0. Therefore, at the point x equal to 0, numerator and denominator both are the 0 values. Here observe that substitute x equal to 0 directly, then we have a problem like this, and suppose that evolution is like that: limit x tends to 0 sin x upon x, sin x upon x, multiply with, here the given function is divided into two categories: sin x upon x multiply with 1 upon 6x, multiply with 1 upon 6x. So that is sin x into 1 is sin x, x into 6x is 6x square. So that is equal to, here limit x tends to 0 sin x upon x multiply with limit, according to the multiplication rule of limit, the f of x and g of x are multiplied together, then we can separate limit give to both the functions. Limit x tends to 0 1 upon 6x. So here that answer is finite. We know the facts of limit x tends to 0 sin x upon x is 1, but here observe that the 1 upon 6x, here there is no factor in numerator with cancel out denominator. So therefore we can directly substitute x equal to 0, and here substitute x equal to 0, we get 1 upon 0, that is infinite. Infinite multiply with something, that becomes an infinite. So that answer is not finite. So that answer is not finite. Now our next aim is to obtain the finite answer of this type of function given. So our next concept is how to obtain finite limit of such type of functions. So that process is, here observe that numerator is 0 and denominator is 0. So that is the form of 0 by 0. That is the form of 0 by 0. When we substitute x tends to 0, numerator becomes 0 as well as denominator becomes 0. So that is form of 0 upon 0. So that are the forms: 0 by 0, 0 by 0, infinite by infinite, infinite by infinite, 0 cross infinite, infinite minus infinite, 1 raised to infinite, infinite raised to 0, and 0 to the power 0. All are called indeterminate forms. All are called indeterminate forms. Indeterminate forms. Then 0 by 0, infinite by infinite, 0 cross infinite, infinite minus infinite, 1 raised to infinite, infinite raised to 0, and 0 raised to 0. So there are 7 types of indeterminate forms in our chapter. So first we try to evaluate when after substituting the limits, the form becomes 0 by 0. So how to evaluate 0 by 0 form? So what is the working rule? So now the evaluation method of indeterminate forms will also known as the L-Hospital rule. You can discuss further the what is saying L-Hospital rule. Now how to evaluate limit when function of the form 0 by 0. That is our question. Function of the form 0 by 0. So that is what is our working rule. The solution is any function of the form 0 by 0, then how to evaluate the limit of the given function. So there are some steps. Step 1, first differentiate numerator and denominator with respect to x. Then step 2, to substitute our function of the form like limit x tends to a, f of x upon g of x, and at x equal to a, f of x becomes 0 as well as g of x becomes 0. So that is the meaning of 0 by 0 form. Then, so in this case, first differentiate numerator and denominator with respect to x. So numerator and denominator differentiate with respect to x, and next substitute x equal to a in the differentiate instruction. So that is to substitute x equal to a. In the numerator and denominator. Step 3, to check denominator is always not equal to 0 at x equal to a. To check denominator is not equal to 0 at x equal to a. If denominator is 0 at x equal to a, then again differentiate numerator and denominator with respect to x. Hence substitute x equal to a. That process of differentiating the denominator and numerator with respect to x is continue till denominator is not equal to 0 at x equal to a. So that is the procedure to find finite limit when the given function having form 0 upon 0 at the point x equal to a. So according to that process, we will evaluate the function limit x tends to a, f of x upon g of x. So in general, that process will be known as L'Hospital rule. So that whole the process will be known as L'Hospital rule. L'Hospital rule. That process will be known as L'Hospital rule. So that is the procedure. According to that process, we can calculate some examples using L'Hospital rule. So now go on examples.